Metallic bond. And that's right. Metallic bond is a type of bond. Is a type of bond formed by just one element. So far so good. This is the first time we are seeing that a bond is formed by only one element. When we're talking about ionic bond, we look at two elements, metals and non-metals, right? Positive ions and negative ions. When we talked about covalent bond, we looked at two elements at least, non-metals coming together last week. Today we have seen some examples also, ACl, NH3, and so on. But now this is the first time we're seeing a bond formed by only one element. Only one element. So that's the first thing you should know. So this is the type of bond formed by only one element. Now the next point is that the metallic bond, the metallic bond is the force of attraction, is the force of attraction between the positively charged, the positively charged surface or nucleus. Let me use nucleus. Positively charged nucleus of a metal. Should I use nucleus? No, I should use atom. Positively charged atom of a metal and the electron cloud due to the electrons donated by the metal. So what metallic bond is all about is metals, they give out electron. Metals are known. In fact, the first thing you should know about a metal is an atom that ionizes by losing electron. So when a metal, like sodium, for example, this sodium, and sodium has many shells, three shells. Now, this sodium, Na, we lose electrons to give out electrons. From time to time, the sodium atoms, inside the sodium, you have plenty atoms of sodium. Those plenty atoms, they will give out electrons because sodium is 11. That's 281. Sodium can only give out one electron at a time. So every atom of sodium, every atom inside sodium can give out only one electron. Now, when you give out this one electron, all the atoms inside sodium has plenty atoms. Just like humans, just like everything is like, we all have plenty atoms that make us up. Now, sodium has plenty atoms inside it. Each of those atoms will start giving out smaller electron, which is this one. These electrons will now gather together to form what we call electron cloud. This is called the electron cloud. The electron cloud will now surround the sodium. Remember that the sodium will give out one electron to become Na plus. So the surface of the atom is now positively charged. Why? Because the atoms inside sodium, they are giving out electrons, so they are having positively charged. So sodium has a positively charged surface. All the atoms are now positively charged. Now that positively charged atoms will now attract the negatively charged electrons, forming the cloud or C. You can call it electron C, electron cloud or electron C. So the attraction of this positive and negative is what is forming the metallic bond. So it's only sodium now that is contributing to everything here. So that is a type of bond formed by just one element. You don't need another element to come together. No. The sodium just lose electrons and form electron cloud. So that's it. Okay. Only metal, of course. Non-metal, they don't lose electron. they don't, they accept electrons. So the next point is that the strength of a metallic bond, the strength of the metallic bond, the strength of the metallic bond depends on the number of electrons, depends on the number of valence electrons, number of valence electrons. So the strength of the metallic bond depends on the number of valence electrons. That means that calcium, which is 20, will form a stronger metallic bond than potassium, which is 19. Why? Because calcium is 2882 and potassium is 2881. So calcium always gives out 2 electrons, potassium gives out 1. So if they should ionize 10 times, it means that calcium has given out 10 times, meaning that it has given out 20. Abi? Then potassium ionizing 10 times, how many electrons will it give? 10. So the more the electrons, the stronger the bond. So if there are many electrons here, it will be strong. That means that the metallic bond depends on the number of electrons. So the more electrons are crowded here, the stronger the bond. So between potassium 19 and magnesium 12, which one has stronger metallic bond? Eh? Magnesium. Why? Because magnesium has 2 electrons to give out. Why potassium has what? Just 1 to give out. So if these two should ionize 10 times, potassium will give out 10 electrons into the cloud, into the sea. One magnesium will give out 20. And the more the electrons, the stronger the metallic bond formed. So the strength of the metallic bond depends on the number of valence electrons. So jam question, which of these elements, has the strongest metallic bond? Which of these elements has the strongest metallic bond? So what will be your answer? Which of these elements has the strongest metallic bond? Which of these elements? Yes. Yes, my friend. What do you think the answer will be? Aluminium. Yes, thank you. So aluminium is 13. So aluminium is 13. That's the strongest metallic bond. So you have 283. Then magnesium is 12. So that's 282. So just 2. Calcium is 20. That's what? 288 and 2. So sodium is 11. Sodium has the weakest metallic bond. No wonder the group 1 are very soft. You can cut sodium with knife. It's a metal, but it's soft. Potassium is even softer. Potassium can be break with your hand. You can cut sodium with knife, but you cannot break aluminium with your hand. It's not possible. You know aluminium now, so it's strong. Magnesium likewise. So they have weak metallic bonds. That's why the melting point of potassium is 63 degrees Celsius. Melting point. Imagine how low it is. Let me go for the metal. One sodium is what? 97. Why zinc? Zinc is 419. See how high zinc is. That's what the metal should be. Metal should have high melting point. High melting point. Something like iron now. Iron can melt around 950 degrees Celsius. That shows you're a metal. But look at sodium and potassium. They melt at this temperature, less than that of water. Although water one is boiling, but I'm just saying melting point of sodium and potassium is low because of their metallic bonds. It's very, very weak. So take note of that. So once JAM has question for you, let me tell you the truth about JAM. The JAM questions are not hard. It's just that you've not read what you are supposed to read correctly and you have not known it very well. Once you know everything that you need to know, for 2025, you have 25 years past question. If I want to start using past question, I'll start from 2000 till this end, this year that we have. I'll check all the questions I asked under chemical bond. And if I answer those 25 years questions, what would they bring again that is so unique? I don't think there will be anyone. So now I've written this. I want to clean the board. Okay, so I can continue. So the next bond that we're looking at is what we call the hydrogen bond. So hydrogen bond is the next one. Hydrogen bond. So, what is the major significance of hydrogen bond? I'll start from there. The major significance of hydrogen bond is number one. Sorry. Major significance of hydrogen bond is number one. Hydrogen bond causes the covalent molecules. Causes the covalent molecules such as water, ethanol, and ethanoic acid to have abnormally high boiling point. So water has a very high carbon is 12 times 6 plus hydrogen is 1 times 6. This will give us 72 plus 6. This will give us 78 grams. That's the mass of benzene, 70 grams per mole. Now let's check the mass of water. Water is H2O. Hydrogen is 1 times 2 plus 16. That's 18. So you see the gap. Benzene has higher molecular mass than water, but water has higher boiling point than benzene. Why? Because benzene contains only covalent bond. Water contains covalent bond, but also has what? Hydrogen bond. So what is the cause of hydrogen bond? That's what I want to learn next. So water has covalent bond and also has hydrogen bond. Hydrogen bond is the reason why water boils at what? 100 degrees Celsius, very high. For this mass, 18, 100 degrees Celsius is very high. Benzene that has 78 as the mass, the boiling point is what? Is 80 degrees Celsius or 80.1 C. Imagine even as far as the mass is higher than water, benzene still has a lower boiling point compared to water. So why would water have higher boiling points than benzene? Because water contains what? Hydrogen bond. Now the next thing you should know about hydrogen bond is hydrogen bond increases the solubility, solubilities of covalent molecules. Hydrogen bond increases the solubilities of covalent molecules. So covalent molecules in water, they don't dissolve in water, but if they contain hydrogen bond, they will dissolve in water. So any covalent molecule that you know that should not dissolve in water, if it does, it means it has hydrogen bond. So what is the hydrogen bond? Now, let us now know what hydrogen bond is. So hydrogen bond, let us now know it. Hydrogen bond is a bond formed. It's a bond formed by the attraction. So let me put it this way. It's a bond formed by the dipole attraction between hydrogen atom from one molecule, as usual. No need to between hydrogen atom from one molecule and a very electronegative element from another molecule. So that's hydrogen bond. Hydrogen bond is a bond formed by the dipole attraction between hydrogen atom from one molecule and a very electronegative element from another molecule. So it means that hydrogen bond cannot exist. Hydrogen bond cannot exist in one molecule. No, it exists between molecules. Yes. So that means you cannot find hydrogen bond in sitting inside one molecule. There's no hydrogen bond inside one molecule. There's hydrogen bond between two or more molecules. Let us now see how it works. Let's see how it goes. But take note that hydrogen bond can only exist when hydrogen is attracted to a very, underline this word, a very electronegative element. Example of this electronegative element that are very, very electronegative is fluorine, which is the most electronegative element in chemistry, followed by oxygen, which is the second most electronegative element in chemistry. Then we have chlorine and we have nitrogen. So these four guys here, whenever they are reacting or interacting or attracted to hydrogen, they tend to drag the electron closer to themselves than hydrogen. So let's find out something. Now look at this. Let's take HCl as a case study. Let's take HCl as a case study. This is one molecule of HCl and another molecule of HCl. Now there are two molecules of HCl. Please pay attention so you understand why hydrogen bond looks like. Now hydrogen has one electron. Chlorine has 7 in the outermost shell. Chlorine is 17, 2, 8, 7. So we have 1, 2, 3, 4, 5, 6, 7. So hydrogen is somewhere here, bringing that one like that. So they want to now share. So hydrogen now has 2, chlorine has 8. But because chlorine is more electronegative than hydrogen, chlorine will try to drag the electrons closer to itself. So leaving hydrogen very far from the electrons. So electrons will now be somewhere here, near to chlorine. Now, this electron that we share, these two here, they are very far from chlorine. So what will this thing create now? This will now create a negative what pole. This side that has no electron will now become a positive pole. Now, watch. The second side, now what we have the hydrogen and Cl, they are doing the same thing again. So here we have the electrons flows, we have the negative pole, and here what do we have here? What we have at this side here? Positive pole. So this plus and minus, they will now what? Attract. So the attraction between the what? The dipole. This is a dipole. Di means two. Positive and negative poles from two molecules. Negative from this molecule, positive from this molecule, we now form the what? Hydrogen bond. We now form the hydrogen bond. Hydrogen bond exists when hydrogen is sharing electrons with very electronegative elements. So there's a minus here and there's a plus here. That attraction, according to physics, that says unlike charges do what? Attract. This is not working. But it's a 16 now. It's working. It's working now. Why are you not finding it? It is true. Look at the equipment. It's true. So what do you now do now? You enter the AC. Okay. So now this attraction between the negative and the positive attracting one another or each other is known as the what? Hydrogen bond. So take note, in case in JAMB exam, they ask you this question, that is what hydrogen bond is all about. So it's a dipole attraction between hydrogen atom from one molecule and a very electronegative element from the other molecule. So take note of that. So the next one I'm going to is the van der Waals forces. Van der Waals. This one, like the name implies, the force. It's not a bond per se, not an ionic bond. Ionic bond is not a bond. Ionic bond is an attraction. I've already said this again and again. Ionic bond is an attraction. So ionic bond is not a true bond. Man of God, where's your past wisdom? He's who has past wisdom. Perhaps you have past wisdom. Yeah, please help me use it or use it. You cannot talk. You cannot talk.
Wow.
She move ahead. So van der Waals forces. Van der Waals forces are very weak forces. Of course, are very weak forces. Van der Waals forces are very weak forces. Van der Waals. These are very weak forces that exists between covalent molecules, e.g., covalent solids like graphite, covalent solid like graphite, covalent solid like graphite, comma, iodine crystals, and dry ice. What is dry ice? Ice is smoke. Is what? Thank you. Solid CO2. This man of God, this time no book. It's just that his brain has been washed away. The layers of the brain, you know when the layers of the brain have been washed away or eaten up, then your brain will not be forgetting, losing memory. That's what we call multiple sclerosis. Yes, the medical issue. The medical issue. Now, another thing again I suspect is if they give so much religion, then the person's brain is taken it automatically. They give you religion, your brain will be taken away. You know why? Because you will no longer be able to think like you know able to think. So, iodine crystals, dry ice, what do you have with the camphor? So the camphor in your house contains
that one at home.
contains van der Waals forces. Have you ever noticed that camphor has van der Waals forces? How would you know? It disappears, it doesn't melt. Does it melt and not the liquid? No. Who say yes? So all these ones here, because all of them here, graphite, iodine, dry ice, camphor, when you melt them, what happen to them? What happen to them? If you melt them, if you carry camphor inside fire, what will happen? Yeah, it's not towards gas. Thank you. So it will just change from solid to gas. You need to see. You know the reason why you cannot do it in the house is that you are not sure of the gas, whether it's going to be poisonous to your mucous line or not. So when you want to do experiment like that, you need to be in a fuel chamber.
You need to wear face mask.
Yes. Face mask is rubbish and it's scam. Because with the face mask, the person is carrying beans and pass on front, you see the beans will enter your nose. So I don't understand why the face mask is good to protect you from that. These are going beans, if they carry pass on front of face mask, it will break the face mask down. So solid to gas is called what? Sublimation, right? So any solid that can sublimate or that can sublime rather is called a what? Sublimate. So any solid that changes from solid to gas is a sublimate. And why would we do that? Why will a solid change from solid to gas? Is because the solid has a very weak bond, and that weak bond is what? Van der Waals. So van der Waals force also exists in what? Covalent liquids too. So van der Waals forces exist in covalent liquids. So you can also find it in covalent liquid, like the spirit that you have in the Bali Salon. That spirit, you put it on your palm. After some time, the spirit will vaporize. It doesn't take too much time, sir. Spirit will dry up immediately. So your hand will feel cold. Why would your hand feel cold? Why would you feel cold on your palm? Yes, thank you. It has observed heat inside your body. That heat inside your body has dried the spirit away.
So that's the chemical reaction.
That's the what?
Endothermic.
Yes, that's endo. Absorption of it. Okay, that's no hard. Sharp. I say don't talk kind of that thing. I beg. Simple to me, no one people know. The chicken. Chicken as what? Now, so Van der Waals forces are responsible for the vaporization. Another word for vaporization in organic chemistry is what? Evaporation. Yeah, Abi? What those fuel, what do they call them? They say they are what? Is the name they use for them? All those fuel. They say that they are very, very something.
They're very
It's a very, very volatile. It's the word they use. Flammable.
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 Highly
Yes.
flammable.
So why can't we say flammable and inflammable?
No difference.
They don't know which small for this class. So Van der forces are responsible for vaporization of covalent liquid. So anything that is weak, e.g., your spirit, so full stop, anything that doesn't have power to stay long, thing just disappear once. That means that thing vaporizes easily. Yes, it does vaporize easily. So anything like that is called volatile liquid. So volatile means e no dey waste time dey disappear. So volatile liquid dey evaporate very fast, and once they are volatile they are dangerous. Anything like that is dangerous, it catches fire sharp sharp. So they are flammable. So volatile liquids are flammable. They are very, very flammable. So please take note of these things. So there are two types of Van der Waals forces. We have what we call the dipole-dipole attraction. Dipole-dipole attraction. So two types of Van der Waals forces. We have the dipole-dipole attraction. Second one is called the what? London dispersion bond. But we don't usually learn all these ones at this level. London dispersion force. We just know it, yeah. So we have London dispersion force and dipole-dipole attraction. So recall any bond formed by atoms with wide electronegative difference. With wide electronegative difference is an ionic bond. See, bond is formed by atoms with wide electronegative difference is ionic bond. I said that in the last class, so that you should remember. Then if the electronegative difference is not wide, it's close, then it is what? Covalent bond or any other bond. But this one is the main thing that you should know. Any bond formed by what? Atoms with wide electronegative difference is an ionic bond. So I'm going to stop this class here because we have treated all the bonds that we need. Please, the past question.
So let's see if you have any.
The topic has ended.
Shit.
What are you shouting for? You're not tired.
Yes.
But you just ate now and never pay.
It's not about food.
It's about what?
It's about the energy that's needed.
The rest now. You just sleep now. Come and give me your back. Yeah, baby. Thank you.
That's it.
I see. What do you You know the done.
Man, where are you pausing this thing? Okay. Hey. Why is your dressing? What inspired this? Hey, man of God. What inspired your dressing?
Thank you, God.